Hello dear students, in this subject hydraulic engineering, today I'll continue the chapter that is dimensional analysis. So this chapter we discussed in the last class that the use and the concept of this dimensional analysis, why it is used, okay, and how it is used. The one method that we discussed, Buckingham Pi method, and in today's class we will discuss this Rayleigh's method, okay. The next and last method of this dimensional analysis, that is Rayleigh's method. This Rayleigh's method is comparatively easier than the Buckingham Pi method. It is simpler than Buckingham Pi method. In this method, we have to the functional relationship between the variables is expressed in terms of exponential relationship, okay, which must be dimensionally homogeneous. It means let discharge is function of this velocity and cross-sectional area. Okay, we know that discharge depends upon the velocity and area, and we want to express this discharge. We want a relationship between the discharge, velocity, and area. So here discharge depends upon these two. So this is called dependent variable, and this velocity and area is called independent variable. So we can write this discharge is as in the exponential form. Means discharge is equal to is a function of this velocity to the power a and area to the power b. Okay. Where a and b are exponential powers which are constant, and that a b value that can be determined by writing the dimension in LH side and RHS side. Means here, because we have to follow the dimensional homogeneity rule, in the LH side we have to write the it is L minus 3. Okay, means this is the discharge dimension. And here this is the velocity dimension LT to the power minus 1 to the power a, and area dimension is L2. That dimension we can write into the power b. So here a and b value we can solve, and after solving the a and b value we can derive the relationship. Okay, so here in this written in exponential form, let y is the dependent variable and x1, x2, x3 these are the independent variables. These variables can be written in exponential form. It's x1 to the power a, x2 to the power b, x3 to the power c, like this. Let's solve this example. The velocity of propagation of a pressure wave through a liquid can be expected to depend on the elasticity of the liquid, represented by Bock modulus, its mass density, established by dimensional analysis, the form of the possible relationship. The possible relationship that we have to derive. And we know the independent variable is k and rho. Dependent variables means the velocity depends upon this k and rho. Okay, function of k and rho. So this we can write u is equal to c rho to the power a, k to the power b. C is a constant, rho to the power a, k to the power b. This is the exponential form of this equation. And we have to write the dimension in the LH side and RH side, both side. So constant has no dimension. Velocity L by t and rho is m by L cube to the power a, and this is the k. K is the modulus of elasticity, Bock modulus. Bock modulus that we know, that is change in pressure divided by rate of change in volume. So this has no dimension, dB by b, only the pressure dimension we have, that is m by L t square to the power b. Okay, so here you have to equate in this LH side and RH side the m power, L power and t power. M power is 0 in this side, here this side is a plus b. In LHS L power is 1, here in this side RHS it is minus 3a minus b. T power is minus 1 here in the LHS, in the RHS it is minus 2b. So you have to solve this a b value. Using the three equations you can solve it. A and b value, a is minus half and b is half. So we can write here a and b value. So this equation can be expressed like this. U is equal to C to the square root of K by rho. C is a constant. Okay, like this. This is the RLS method, and like this we can solve any problem. Here, next example, if you see, find the expression of drag force on a smooth sphere of diameter d, moving velocity is v, and fluid density is rho, and dynamic viscosity is mu. It means the drag force is a dependent variable which depends upon, here it is written, drag force depends upon means function of this velocity, diameter, rho, and mu. These are the independent variables. So you can write in exponential form k into d to the power a, b to the power b, rho to the power c, mu to the power d, where k is a constant. Then we have to write the dimensions of in LH side and RH side, right hand side and left hand side. So here MLT minus 2 force dimension. Here diameter dimension is L, which is L to the power a, velocity LT minus 1, ML3 minus 1 there is rho, and mu is ML minus 1 T minus 1. Mu is the coefficient dynamic viscosity. Mu is this is actually shear stress divided by du by dy. Okay, so shear stress relation, shear stress means pressure. Pressure is ML minus 1 T minus 2. Here it will be LT minus 1 divided by L. So it will be ML minus 1 T minus 1 to the power D. So here the powers of M, L, L and T we have to write. So there will be three equations. C plus D will be 1, A plus B minus 3C minus D 1 minus B minus D minus 2. Okay, so three equations, but unknown is A plus B, C, D, 4 unknown. That means we cannot solve the value of A, B, C, D. So in this type of, in this specific problem, okay, we have to find where the unknown is more and equation is less. In this case, we cannot solve the value of all A, B, C, D. So here we have to find which is important. But three of them can be expressed in terms of fourth variable, which is most important. We have to find which one is important. Out of these four variables, which variable is more important? And all other variables can be expressed in terms of this fourth variable. It means A, B, C value. Let here in this drag force actually this mu, the coefficient dynamic viscosity role is most important. It is vital. So A, B, C power, which are means the powers of the which are unimportant variables, can be expressed in terms of D, which is most important variable. D is the power of important variable mu. So C can be written in terms of D, B can be written in terms of D, and A can be written in terms of D using these three equations. So here A is minus 2 minus D, B is 2 minus D, C is 1 minus D. Okay, so all the powers we have to write here in terms of D. So here this we can simplify, and it will be rho B square D square into rho mu divided by rho B D to the power D. D value we don't know. That's why we can write this rho B square D square function of mu by rho B D. So in this way the drag force can be expressed. Okay. Coming to next example, efficiency eta of a turbine fan depends on the density rho, mu and angular velocity, okay, omega and diameter d and discharge q. So express this eta in terms of the dimensionless parameter. So here the eta is function of rho, mu, angular velocity, omega, diameter d and discharge q. Okay. So here in the exponential form we can write rho to the power a, mu to the power b, omega to the power c, d to the power d, q to the power e. And dimensions in left hand side and right hand side we can write. Efficiency has no dimension, m to the power 0, l to 0, t 0. So here k has no dimension, so it's not required to write the k. Rho ml minus 3, mu ml minus 1, t minus 1, angular velocity t minus 1. Angular velocity is rotation per unit time. So it will be t minus 1. D dimension is L. Q dimension is LQ minus t minus 3. T minus 1 to the power e. So here the powers of M, L, T can be equated with the powers of the MLT in the left hand side. So 0 will be A plus B, 0 will be minus 3A minus B plus T plus 3A, and 0 will be minus B minus C minus E. So here we can mark here the three equations, but the unknown is 5, A, B, C, D, E. So in this type of problems, again, since there is 5 variables and 3 equation, means 2 differences there. So you have to find 2 variables which is the most important. And other variables can be expressed in terms of these 2 important variables. Means powers. I'm saying the powers. Means A, B, C, D, E. Okay. Next important variable here, mu and q, the most important. The powers of the mu and q can be expressed with the powers of these unimportant variables d, omega and rho. Okay, so we can write the mu and q, mu power is b, q power is e. So all these a, b, c, okay, sorry, a, c, d, these three can be written in the form of this b and e, b and e. Okay. So if you're using these 3 equations, we can write this a is equal to minus b, c is equal to b plus c, d is equal to minus 2b plus 3. So now we can write the values of a, b, c, d in terms of b and e. So it will be k into mu by rho omega d square to the power b, q divided by omega dq to the power a. Okay, so here b value, e value we don't know. So we can write this eta as function of mu by rho omega d square and q by rho omega dq. Okay, so like this the problems can be solved. Okay, thank you so much.